In this lesson, let us see an example of how to find the point of intersection of three planes. In this case, it is a unique solution category by using the row reduction method. Okay, look at the three plane equations. The first plane pi1 is 3x plus y minus z equal to 11. The second plane equation is x plus 3y minus z equal to 13. The third plane equation is x plus y minus 3z equal to 11. First, let us make the coefficient matrix. Here, I should start with this. The coefficients of x, y, z in the first equation is 3, 1, minus 1, 11 it goes. What you do is you always prefer to write how this first term is 1. In case out of the three equations, if any of the equation is having the coefficient of 1, that you prefer to write first. You can write these three equations in any order, so it doesn't matter. So these two equations are already having coefficient of 1. It will be easier for calculations to multiply or to understand what has to be multiplied and subtract to make it 0. So I'll write the second row second equation in the first row. So the coefficients of second equation A are 1, 3, minus 1, 13. And the second row, I'm going to write from the first equation coefficients. 3, 1, minus 1, 11. The third row, I'll write here down 1, 1, minus 3, 11. So if I want to make this 3, this term is 0. If I want to make this term 0, then here the number is 1. So I can multiply this 1 by 3 and subtract with this. So like unitary method, if it's 1, the calculation handling would be much easier. Okay, if all the coefficients are not equal to 1 for x, you may divide by, in case if you're taking this row, you can divide the whole equation by 3 and make it 1. Okay, if you want, otherwise you can handle it by keeping 3 itself. Your choice. Okay, so my aim is to make this term 0 in the second row and this term 0, the first term in the third row 0 in the next matrix by using row reduction method. So my first row remains same. You write that as it is, 1, 3, minus 1, 13. Second row, this is new R2 is whatever I have R2 I have 3 should be subtracted with the first row. First row I have already 1. So I multiply the first row by 3 and subtract. So new R2 is this, the current R2 minus 3 times of R1. So this rule I'll follow to make this 3 as 0. So whatever rule I'm using here, I have to follow the same thing for the remaining terms in the same row. Fine. So 3 minus 3 will become 0. So I'm writing 0 here. For the second term, for this, what I can do, the rule is R2, that is 1. I'm writing on the right side, the calculation. 1 minus 3 times of this term, minus 3 times of 3. So 1 minus 9 will give minus 8. So that would come here. Fine. Next, to get this third term in the second row, the rule is R2, which is minus 1 minus 3 times of the corresponding term in R1, which is minus 1. Minus 1 plus 3 will give a positive 2. So I'm writing 2 here. Coming to the next term, R2 term is 11 minus 3 times of the corresponding term from the first row, that is 13. So this makes 11 minus 39, which is minus 28. Okay, so our aim is to make this term 0, this 3 0. We made it in this attempt. Okay, in the third row, our aim is to make this 1 0. And already you have the row 1, you have 1, so it is very easy. Now you can subtract these two rows, you can easily make it 0. So my new row 3 is nothing but R3 minus R1. Okay, 1 minus 1 will become 0. 1 minus 3 will become minus 2. And minus 3 minus of minus 1. Minus 3 minus of minus 1. We'll make it as minus 3 plus 1, which will be minus 2. So this term also minus 2 and this also minus 2. And the last term is, we have 11 here and we have 13 here. Okay, 11 minus 13 gives minus 2 again. All right. So our aim in this was our aim is to make these three terms 0. We made in our first attempt, we made these two terms become 0, right? Next, we are going to make the second term in the third row, we have to make it as 0. Fine. To make this 0, the previous case we used first row. But here, to make this term 0, never use the first row. If you use the first row, what will happen is, this corresponding term, this term is 0, the corresponding term is a non-zero. So if we use the first row, then this term will automatically become non-zero number. Okay, so what you have to do is, since we already made the second row, first term 0, always you have to use second row and third row to make the third row second term to 0. Clear? Okay, so what we can do, here we have negative 2 and here it is here you have negative 8. So you can multiply by 4 and make, right? So no changes in the first and second row, so you write as it is 1 3 minus 1 13 0. If you want, you can multiply by minus, or you can divide by 2 also, because all are even numbers. You can divide to reduce it. I'll take as it is, minus 8 2 and minus 28. Okay, here third row, how we can do is, I multiply this third row by 4 times of R3, which will give minus 8. And I have to subtract with R2, minus R2. Fine. So since these two numbers are 0 already, so the first term in the third row has to be 0. And here second term we already planned here. Minus 2 you multiply by 4 makes it as minus 8. And if you subtract with minus 8 from the second row, it becomes 0. Then coming to the third term in the third row, this minus 2 should be multiplied by 4. So 4 times minus 2. And you have to subtract this answer with a corresponding term, which is 2. You will get minus 8 minus 2 will make it as minus 10. So that should be the term over here. Next, coming to the last term. The rule is 4 times the row 3. So 4 times minus 2 and subtract with the corresponding term. Corresponding term is already minus 28. This is minus 8 plus 28 will give 20, positive 20. Fine. Okay, if you see in the last video I explained, if this is h, right? If this is not equal to 0, then you will get what? Unique solution. So this is h and this is not equal to 0, we'll get unique solution. So how it is? Minus, this is actually 0x plus 0y minus 10z. So you write 0x plus 0y minus 10z equal to 20, which means minus 10z is 20 and z will be minus 2. We got the value of z. We can get by substituting these values in the value in the previous two rows, we can get the corresponding y and z values. From R2 we get 0x minus 8y plus 2z equal to minus 28. Okay, which means minus 8y plus 2z. Instead of z, we can substitute this value of negative 2. So we'll get minus 8y minus, if we plug in this 2 times minus 2 equal to minus 28. So this gives minus 8y minus 4 equal to minus 28, minus 8y equal to minus 24, and y should be equal to 3. Fine. We got the values of z and y. Next, we need to get the value of x by plugging in these values in the first equation. If from the row 1, you can get to know that the equation is 1x plus 3y minus z equal to 13. Right? 1x plus 3y minus z equal to 13. You have already z value as negative 2 and y value as 3. You plug in these values in. So you'll get x plus 3 times of y is 3 minus of minus 2 equal to 13. X plus 9 plus 2 equal to 13. X plus 11 equal to 13. And x equal to 13 minus 11 is 2. So the unique solution, all three planes make point of intersection, right? So assume first and second plane make a line of intersection. The third plane passing through that line, hence it makes a point of intersection. What is that point of intersection? The solution is x value is 2, 3, minus 2. Fine. If this question comes in paper 1, non-calculator, you may have to do this. Or you can use a regular simultaneous equation method of elimination you can use to find the same solution. If it comes in paper 2, you can use GDC. Whatever GDC use, Casio, FXCG, 20, 50, whatever model, or TI Inspire. You can see in equations, there's an option to solve simultaneous equations. In simultaneous equations, you pick 3 variables and plug in these coefficients. These 3 equation coefficients you plug in. This matrix basically you need to put. It returns the values. If this question comes in higher level paper 2, it can come for 2 marks. Okay. Then if you are doing all this working in paper 2, it is waste of time. You will just get 2 marks. Okay. In paper 2, if it's a calculator paper, you have to use calculator only to solve this. Anyhow, it's a unique solution. There are no parameters in this equation. All are constants only. So you can easily plug in and get your answer. Okay, if it comes in paper 1, then you may have to show this method, either this method or a regular method of elimination method by using simultaneous equations you can use to get the solution. In the next video, let us see 3 planes makes no solution and infinitely many solution category examples. Thanks for watching.